A very warm good morning to everyone. Thank you, all the attendees, for joining us today. I'm Sakshi, welcoming you all on behalf of Solar Quarter and First View Group to our webinar on ESS Market Outlook in India. As we all are aware that the smart storage system is a state-of-art technology and the energy management solution designed for owners who plan to implement effective residential energy management. Today, in the 60-minute Tech Talk webinar with Mr. Sai Charan, who is the technical director for Genco Solar, the event will highlight how, in India's context, the ESS roadmap will help both the policymakers and utilize the decision making related to investment and implementation of ESS to support the integration of renewable energy sources, leading to a more reliable and low carbon grid. Before handing over this session to our panel speaker for today, I would like to take this moment to remind all our attendees to post their questions in the Q&A chat box, and our speaker will take up those by the end of the session. And I would request my team to play the promotional video now. Since we are short on time, I would request my speaker to begin with his presentation for the day without any further delay. Over to you, Mr. Charan.
Thanks, Sakshi. Very good morning, everyone. Uh, I'm really very sorry for the delay which has happened. So, however, going into this particular session, so today my talk on the existing scenario of ESS is going to focus more on the upcoming or the penetrating technologies, which is what is required for our PV and ESS landscape for Indian market. So, with specific to that, let me just share my screen. Hope you all can see my screen.
Not yet. Yes, it's visible now.
Okay. Yeah. So more predominantly, just before going into this particular technology talk, if you just try to understand what Jinko Solar and maybe what we generally mean for. So Jinko Solar is a globally vertical integrated manufacturer specific to PV kind of technologies. And we are not just a kind of module manufacturer, but yes, we try to derive ourselves more on the technology fronts as a technology leader, which is why right from the days of 2006, right from the day of our penetration or right from the day of our uh, conviction specific to this particular PV market from 2006 onwards. We have provided the best in class kind of technology products, which are more specific to high efficient, which means high power density kind of technologies, or even specific to high energy density kind of technologies. On those particular fronts, we are constantly providing M10 kind of wafers, which is 182 by 182 kind of wafer size. Or before that, we were providing on P type specific to 156.75, or then we made a kind of trend for the people to follow specific to monoperk kind of technologies with 158.75 and then with 163.75 with the tiling ribbon. All these kind of technology optimizations were completely driven by Jinko, and wherein which the other competitors started following our footprints specific to these particular technology aspects. And in this particular segment, even we thought of limiting ourselves only to PV kind of segment, but yes, even on the energy storage also, we started venturing ourselves into this particular segment in providing a kind of value addition on the aspects of technology front specific to ESS part as well. So just before going into that, if you just try to see what kind of numbers that we portray to the market and what we hold within the market specific to market share, and by the end of this particular month, probably we'll be crossing around like 130 gigawatt capacity kind of a delivered capacity across the globe. And we operate in 8 regions, and within this we easily can see that we have our footprints in more than 156 countries. And specific to Indian market, if you ask us, we have a decent market share of beyond 27% kind of thing. And for last year we have touched up close to around like 31%, 32% kind of market share. And for the last consecutive 3 years, if you ask us, so we are crossing beyond 22% kind of market share for Indian market. And specific to the module capacity or the manufacturing capacity per year, if you ask us, so as on date, we will be standing at around like 52 to 55 gigawatt capacity for this particular year. And going forward, by the end of next year, we may be touching around like 70 to 72 gigawatt kind of capacity. And this complete approach, why we could achieve these particular numbers, is all because of the kind of R&D capabilities which our team generally holds in just breaking our own cell efficiency records itself. So that's what is happening within our technology kitty itself. And more specific to this, if we just try to see, we have more predominantly on the fronts of R&D segment itself. We try to develop certain new kind of technologies as well, not just limiting ourselves only to PV, but yes, even on ESS as well. So it's like we are even trying to go with our own factory specific to ESS part, where in which we just try to procure only the battery part, and rest everything we are trying to do it ourselves, where in which PCS also, specific to PCS also, we are trying to have our own consortium, which is what is going to be there across the globe. So that's what we have specific to ESS, and this is a kind of typical classification on the PV segment. On this particular PV segment, we can see that P-type monoper kind of technology products is completely going into saturation mode, which is why we can see that there is no room left, or there is no scope left for this particular P-type technologies to optimize further to provide any kind of high energy density kind of technology or high power density kind of technology, which is why N-type technology has emerged in the market. And we tested this particular N-type product in the last 4 years on DG segment, where in which we easily can see that this particular N-type technology, we moved from first generation of PERT technology to second generation TOPCon technology, where in which the PERC lines are highly capable to produce these particular TOPCon products as well, which is why more of augmentation is going to happen on these particular existing PERC lines to TOPCon. And capacity wise, if we just try to see, out of 340 gigawatt capacity of global manufacturing, 280 gigawatt capacity is completely focused towards PERC lines, or the rare contact kind of technology. And that particular rare contact technology definitely helps in converting themselves towards TopCon rather than any other N-type kind of technology. And going forward, we easily can see that TopCon is going to take the lead, and it's going to have its own prominence for the next 8 quarters kind of timeline. And going forward, we easily can expect that interdigited back contact circuit, or TBC, which is the combination of TopCon plus interdigited back contact circuits, and then perovskite or tandem perovskite kind of junctions can be expected maybe down the line after 80, after 4 to 6 years kind of timeline. So that's what is expected within this futuristic perspective of PV kind of technologies. And more predominantly, if we just try to compare the existing P versus N, where we easily can see that the kind of benefits what generally you get with uh, P versus N, comparing P versus N definitely will have the better advantage on the power density wise, just because that for the same dimension, we easily can see that this particular 2278 by 1134, where if P module is trying to generate you 570, 575, or 550 kind of watt peak, where N module, this is the dimension of the same dimension of the N module within the same dimension, which means within the same area, you easily can generate 15 to 20 watt peak extra. So that way, we easily can see that power density of these particular technology products within N type is going to be more. Not just limiting only to power density, but even on the energy density part as well. If we just try to see how exactly the within the energy density part as well, we easily can see that temperature coefficient wise, comparing P versus N, normally P stands at minus 0.35% per degree C rise in temperature, whereas N generally stands at minus 0.3%. And specific to the revised or the optimized kind of TopCon cell, which is there with a rectangular wafer kind of thing, where in which we have achieved even this particular value of temperature coefficient to minus 0.29% per degree C rise in temperature. That way, we easily can see that 1.5% to 1.8% of extra energy gain can easily be expected with this particular temperature coefficient. Not just limiting to that, but yes, even on the degradation factors as well. With P kind of technology, with PERC kind of technology, we can see that 2% as a first year degradation and 0.55% as a kind of linear degradation. Whereas the same numbers, if we just try to talk with N type, we easily can get 1% for the first year and 0.4%, irrespective of monofacial or bifacial kind of products, can be expected. So compiling these particular two factors of temperature coefficient gain of 1.5% plus 1.2% of this particular degradation factor definitely can value in to increase your expected energy gain towards 3% as a kind of direct benefit. Not just limiting only these particular two factors, but yes, if you are going with a kind of bifacial module where the bifaciality factor of these particular n-type products is going to be far better, where in which we easily can expect that 80% plus minus 5% kind of bifaciality factors can be expected with these kind of topcon and type kind of Tiger Neo series products when compared with normal monoperk kind of technology products, where the bifaciality factor generally stands in between 65 to 70% kind of thing. So that way, all these particular factors definitely add much more value in increasing the energy density part. And specific to the power class availability, if we just try to see, what we are trying to provide for Indian market is more specific to 72 cell and 78 cell in bifacial kind of technology, which means these particular three products are going to be available for our market. If you have any specific requirement on monofacial, definitely this particular 570 watt peak is the maximum power class, or 575, which can be expected in monofacial. And within bifacial with 72 cell, we easily can expect 570, and with 78 cell you can even expect up to 620 watt peak kind of power class as well. So this is more related to comparing P versus N, where we easily can see the delta, whatever is the extra energy gain which we are getting. So with this particular delta, we easily can expect that the premium benefit, what exactly you get with N type, is going to stand not less than 2.5 cents per watt peak. So that's a direct takeaway which you easily can expect. And just because of that, your LCO is getting reduced, your IRR is going to be increased, and definitely adds much more value in optimizing your entire project cost, more specific to that. And more predominantly, if we just try to talk about energy storage products, yes, we recently ventured in this particular segment as well. As a technology leader, we want to make our footprints also in this particular segment, which is why uh, in this particular energy storage segment, we started providing starting from 1 kilowatt hour onwards till megawatt hour kind of solutions. So specific to this, any kind of residential requirement, more predominantly what we are trying to do is like for North Asian market, where we are trying to provide this particular residential storage segment products, which is as per the core requirements of that particular region, where it can be used as a kind of simple powerhouse on any kind of residential usage as well. So which means starting from 1 kilowatt hour to 50 kilowatt hours kind of requirement as well, these particular small cabinets can be utilized within this particular RESS kind of solutions or systems. And typically for any kind of industries, for any kind of spinning mill industries or textile industries, if you have a kind of specific requirement up to 1 megawatt hour, this kind of cabinet solutions very well can help you in catering the needs, whatever is required to whatever is required in catering those particular energy requirements on the name of energy storage part. And also these can easily be utilized as a kind of small powerhouse to support the grid as well, not just limiting itself as a kind of standalone system, but yes, these all can be interacted with grid, wherein which this generally comprises of simple PCS battery bank along with BMS battery management system, and then PCS connected to the EMS part. As per the need and requirement of the grid code conditions, it easily can work as a standalone system and even as a kind of grid interactive system as well. So this is more typically to these to all those kinds of RTC kind of tenders, where we are trying to provide under the LFP kind of configured systems, which starts with 1 megawatt hour kind of minimum requirement within the container. And within this particular container itself, it is highly compatible enough to provide in both DC coupled system and AC coupled system. And of course, if it is a kind of brownfield system, definitely it is good to go with a kind of DC coupled system or AC coupled system more predominantly, because there will be a kind of constraint on this space. So which is why for any kind of brownfield systems, people try to go with AC coupled kind of systems. And if it is a kind of uh, greenfield project, definitely you can go with a DC coupled system. And again, there is a challenge and constraint with DC coupled systems specific to capacity. So if your requirement is going to be limited to simple single digit megawatt hours, definitely DC coupled systems makes more comprehensive sense on the efficiency and the round trip efficiency of the entire product, which makes more comprehensive sense for that. Just going in particular to that particular thing, if you just try to see, this is one of the containerized solution what we have provided to major markets like Nigerian market, where in which they have a kind of typical requirement of standalone system requirement itself. So which is not directly getting interacted with grid, but just slowly and predominantly we easily can expect that they even will start interacting with grid. The moment when it interacts with grid, we just need to add the future within the energy management system software itself, where in which it has to match to the grid code conditions of that particular guidelines of that particular grid. So accordingly, it easily can be managed and programmed within the EMS itself. So this particular container generally comprises of battery bank, And those particular battery bank is a kind of, we generally try to procure the battery cells from battery manufacturer, and we do the racking and stacking within our facility, and then within the container we try to place it. Also specific to PCS, if you ask us, we have a kind of consortium across the globe with these particular PCS manufacturers, where in which they provide us the best in quality, best in class kind of technology products specific to PCS, which can run on both 50 hertz kind of frequency and 60 hertz kind of frequency, where in which it can cater all kinds of needs across the globe. So accordingly, this particular PCS getting connected to the EMS part and BMS part can easily be configured within this particular containerized kind of solution. And this particular container itself, the container whichever we are trying to fabricate within our facility, is going to have all kinds of safety certifications and normal EN certifications. So that way we are highly confident and highly compatible enough to any kind of PCS for that particular matter. So that way, this particular comprehensive solution is not just a kind of simple product which is having one particular aspect of entire energy solution, but yes, this is a kind of comprehensive solution which can be utilized as a kind of plug and play kind of mechanism can be done with this. And on the fronts of energy density, this, since it is coming with LFP kind of technology, lithium ferrous phosphate, this definitely will portray better number of cycles more specific to charge discharge profile, and the kind of energy density which it generally comes with this kind of LFP is far better when compared with NMH or any other advanced lead acid kind of technology batteries. So that way, this is more sophisticated kind of solution when compared with any other existing energy storage kind of solutions. This is what we are trying to provide to the market, more specifically on the AC and DC coupled kind of systems. So more predominantly for DC coupled systems, we have a limitation of only going with limited amount of megawatt hour kind of solution, just because of the safety reasons as per the code criteria, which is what is being followed across the globe. But yes, if the system requirement is going to stand at 500 megawatt hours kind of thing, definitely AC coupled systems more makes more sense when compared with DC coupled systems. And also the most important aspect is that the entire ecosystem is completely following the trend of AC coupled system. That way, the kind of safety configured materials or the composite infrastructure, whatever is there specific to AC side, is completely well equipped when compared with DC kind of systems. So, which is why the transmission line network also specific to DC link or DC interconnect links is very less when compared with AC transmission line network. That way we easily can see that if we try to go in big scale, definitely AC coupled systems are the only option, which is what is available as on date. But yes, more specific to the kind of transforming efficiencies or efficiency wise, definitely DC coupled systems will have better advantage. But again, it completely depends what exactly is the capacity which has to be considered, and what exactly we are trying to provide within our stacks is, these are 7 different products which we are trying to provide. And these all will have all kinds of applications, starting from providing a kind of voltage regulation mechanism to the grid, or peak load condition match with respect to the grid code conditions, or even supplying power to grid. Within the EMS, it even can be programmed. And also it's more like regulation on voltage and frequency is what which we always need to see that. And as on date, as per the existing RTC tenders, whatever we are trying to receive, these all are coming more specific to standalone kind of tenders. And these particular standalone tenders is a kind of initial mechanism to understand how these particular grid interactive solutions are going to perform in the long run, which is why all the tenders whatever are coming in, they're just coming as a kind of standalone tenders to understand how these particular solutions are going to support grid. And even these particular data points are also much required for the SLDC and NLDC. So that way these particular data points are very much important for these particular 2 years. And after 2 years, definitely we can see all these particular tenders are going to be more relevant, or more predominantly will be having a kind of minimum requirement of grid interactive solutions rather than standalone solutions. So that way we easily can see that. And this is
Uh,
how.
Sir, sorry to interrupt in the middle. If you could just put your presentation in slideshow mode for the
Is it
benefit.
not in slideshow mode?
Uh, no, sir, not yet.
Or no, it's showing me slideshow. Let me stop sharing and let me.
Just
Any,
the full screen, sir.
is it in full screen now?
Yes, sir. On top, if you can see a slideshow option.
It is showing me as full screen only.
Okay, sir. Actually, on top, there's a slideshow option. If you could choose that next to animations.
Let me share my full screen. Is it visible now in full screen?
Yes, yes.
Okay. Yeah. So more predominantly, what I was trying to explain you is like these are different kinds of applications which easily can be catered with these kind of solutions. And as on date, we are just even our NLDC, SLDCs are trying to understand how these particular ESS solutions will support the existing grid infrastructure by not having any kind of any disturbance, by not having any kind of disturbance during congestion times. So which is why all these particular new tenders which are even coming out from NTPC or NHPC or SECI, all are trying to focus more on standalone systems. But just slowly and predominantly, these all will go towards the trend of having grid interactive kind of solutions going forward. And for that particular thing to happen, we definitely should have the EMS with a strong mechanism of having all these kind of support mechanism in place. Also, the most important aspect is that all these particular data points which are related to cater the needs of primary load factoring, or even more specific to smoothing of the grid fluctuations whatever is happening on LVRT or HVRT or any kind of write throughs whichever generally happens. It should support the grid for not less than minimum 250 microseconds kind of thing. So that way, if these particular features are very well equipped within the EMS, which is again getting interlinked or having a kind of compatibility from the PCS, this definitely will help the entire grid infrastructure. So that way we easily can see the kind of penetration of these particular technologies in the existing Indian market. Maybe down the line within 2 years we easily can see that all these particular standalone solutions will turn towards a kind of grid interactive solutions as a kind of primary source, or even we easily can see that these are going to cater the needs of primary energy loads. So that way we easily can see that. And these are simple DC coupled systems wherein which this particular DC coupled system definitely will even cater the loads or needs of grid interactive kind of solutions as well. Of course, as on date, it's only off grid or even standalone kind of system. And this particular mechanism, if we just try to see, this is going to comprise of all kinds of three important units, which is the PCS part is going to be configured here, and battery sizing along with BMS is going to be here. And this is a kind of forced cooling mechanism, which is generally being considered for DC coupled kind of systems. But yes, the moment when you go with forced cooling mechanism, definitely your auxiliary consumption is going to be more. And this is the BESS controller, which is nothing but the grid point connection, and the EMS is going to be here. The entire EMS part is going to be configured here. Yes, this particular system, this particular solution is limited to a specific capacity. We easily can see that this is having a limitation of only 100 kilowatt of AC power, and the maximum output, which is limited for this particular option, is limited less than megawatt hour kind of thing. So that way, we easily can see that this is having a limited capacity, and this can be utilized only for single megawatt hour kind of solutions. Or even we can see that this particular solution is only there up to 200 kilowatt hours kind of specific requirement. So on any kind of industrial loads, for any kind of small load applications, definitely this particular DC coupled systems can be utilized. But more predominantly for the AC coupled systems, this can be configured in megawatt hour scale. So which is why this particular schematic, if you just try to understand, a normal greenfield or a normal brownfield project is going to connect this way, like your modules, and then getting connected to your DC combiner box, and then to inverter, and connecting to the grid interaction point. So this is how general mechanism of any kind of solar PV power plant will be connected. So within this particular system, considering this particular system as a kind of brownfield project, if any tender or any kind of guidelines comes in place specific to converting the brownfield project with a kind of adding additional ESS part just to support the grid infrastructure or support the grid to reduce the congestion during peak load kind of timelines. So this particular aspect can be added on the existing grid interaction point. So which means this particular section is nothing but there's a AC coupled system which will be comprising of entire battery bank along with BMS and then PMS, PCS, and then it is getting connected to the EMS part. So this EMS will interact with grid as per the grid regulations, or whenever any kind of frequency regulation is required or any kind of voltage regulation is required, this automatically will perform its function in just to provide or in just to export power to grid, so such that it will act as a kind of simple powerhouse to reduce the congestion on the grid. So that way this infrastructure of the entire grid can be smoothened with these kind of solutions, and this can be managed in megawatt hour scale. So that way the capacity wise AC coupled systems are having much more prevailing and much more penetrating factor when compared with DC coupled kind of systems going forward. And this particular AC coupled systems or DC coupled systems, since these are coming with LFPE kind of technology, which will have better life cycle with a 0.5C kind of charge discharge profile. So definitely these even can perform even up to 85% kind of, or 90%, 95% kind of depth of discharge, which is being directly provided by the LFPE cell manufacturers itself. So that way we can see better life cycle of these particular products for not less than 6,000 hours of 6,000 cycles we easily can see, which means if we just try to consume one cycle per day also, it is going to cross around like minimum 10 years kind of timeline. So that way we can see the actual benefit with these kind of AC coupled systems. As I was trying to explain you that this is the layout of a simple container of AC coupled system, and within this particular AC coupled system, the center section is completely going to be the battery bank part. So this is, we generally try to procure these cells and we do the stacking and racking within our facility, and within this particular container we try to fit that. And this is completely going to be a kind of natural air cooled mechanism, which is not a forced air cooling mechanism. So this is going to be a kind of liquid air cooling mechanism, which is why we can see that auxiliary consumption of these particular AC coupled systems is very limited. And this is one major part. It's like if you just try to look at the entire ESS solution, three major important units. One is the battery bank, and the second is PCS, and the third is the entire installation or the compatibility or any kind of grid point, interconnection point, or complete EPC of this particular part, more specific to battery bank kind of solution. So within this particular segment, if you just try to see, we are trying to do the racking, and also we have certain kind of consortiums with PCS. So that way we'll have better control on the entire ESS solution. Specific to the installation part, there are many EPC players who are generally compatible and confident enough in just going with a kind of normal inverter and a kind of module installation part. So that way that should not be a challenge. So this particular product is a kind of entire solution which easily can be connected as a kind of integrated solution within the existing solar PV systems, or even it's a kind of plug and play kind of system which you easily can operate and you easily can connect that. So it's more like solar PV modules directly getting connected to the input of this particular PCS will directly act as a kind of inverter, and then converting the same thing or sending the same charge controller unit through charge controller unit to the battery bank for charging these particular batteries. And BMS will regulate whether it is in full charge or what kind of status of charge is going to be maintained along with the DOD of the battery. And from that it easily will manage specific to GPC, which is the grid point connection as per the grid code requirements or the regulations of the grid, or specific to smoothening curve, whatever is desired as per the grid conditions. So this particular GPC along with the EMS part will configure how much power has to be pumped in during peak hours, or it is not required or not necessary. So as per the regulations or any kind of guidelines, as per the tender requirement, or at certain point of time every day, if power has to be exported to grid, even this particular GPC at the point of GPC itself, our EMS can be configured. So on everyday basis, every timeline basis, it can be configured. So that way it easily can be managed specific to exact actual requirements of your tender part. So there's a typical specifications of 2 megawatt hour kind of solution which comes with which comes with 1 megawatt as a kind of AC output with these kind of AC coupled 20 feet container kind of solution. The same thing if you just try to look for DC coupled system, it is having limitation of only 100 kilowatt per container with maximum of 200 kilowatt hours kind of output, which is why specific to application wise, if you just try to see, if your requirement is very limited to small capacities, definitely DC coupled kind of systems makes comprehensive sense. But if you have specific requirement of megawatt hours kind of scale, definitely AC coupled systems makes more comprehensive sense, and which are highly reliable and a kind of plug and play kind of system only. And this is one typical kind of solution which we provided to recently we have provided to Nigerian market, and this is very well going in that particular market, specific to grid interactive solutions as well. Initially they are even trying to touch base with the existing standalone kind of systems to understand how exactly the voltage regulation can happen or not, just trying to check those particular conditions. Slowly and gradually they definitely will convert the existing standalone systems to grid interactive systems. But yes, the solution whatever we are providing, the EMS is highly compatible to program, specific to any kinds of auxiliary kind of catering the auxiliary load requirement or ancillary support services or any kind of primary load services. So it's all together. Even trading also is going to happen going forward down the line, within a span of 2 years to 3 years kind of timeline. Even small residential applications of these particular energy storage products also will try to behave like a kind of trading centers, energy trading centers going forward. So which means during peak hours, any kind of residential user also can sell this kind of power to grid. So that way this is going to be a kind of highly compatible solutions specific to our market. And this is how we try to do. It's like we procure cell from cell manufacturers, and then we try to do our own packing, and then we make that particular rack, and we try to put that particular rack in this particular container. We do the entire testing. Even we place our PCS along with BMS part and EMS part. This is the grid interpoint connection, and accordingly we try to test this particular entire container as per the safety code regulations of UL 1973 or 9540. Accordingly, this entire product is highly compatible as per the required IEC standards or EN standards more predominantly. So this is what, in general, if you just try to see normal module getting connected to your inverter station and then to grid as a kind of grid interpoint connection. If we just try to look at for this particular solution, the same thing, whatever is happening is going to be there, but just instead of getting connected to inverter station, this even directly getting connected to the BESS part kind of thing, where there's a kind of container, which this particular container is going to comprise of PCS, battery bank, and EMS. So this directly will be connected to the grid interaction point, grid interpoint connection, GPC. So that way we can see that the kind of applications which it is going to cater is entire parts of energy trading or ancillary services or regulation of voltage or fluctuation of voltage or smoothing the frequency of the grid. All kinds of services can be provided, which can be programmed within the EMS itself. So that way this will have a simple kind of plug and play kind of system can be considered within this particular ESS kind of solution. With this, I end the presentation and would like to take any questions if you have.
Thank you so much for that insightful presentation. I would request my team to play the commercial video now.
Energy lays the foundation of civilization and gives wings to science and technology. Every progress made by humanity has been driven by the reimagination of energy. Now that our planet has come to the consensus on a more sustainable and low-carbon development model, clean energy, represented by solar energy, is now in the spotlight for the potential value it has to offer. Jinko Solar is a solar energy company dedicated to the R&D and manufacturing of photovoltaic products, as well as a provider of integrated clean energy solutions. The company fulfills its mission to optimize the energy portfolio and take responsibility for enabling a sustainable future, strives for world-class quality with Chinese efficiency, and empower a green future with innovation. We forge ahead with foresight. Throughout our 16 years of growth, we have remained true to our founding values, established ourselves in the industry, and stayed in step with the ever-changing market. we were the first to propose the idea of integrated production capacity. Investing in the sections with the most sustainable value in the industrial chain has helped us gain a competitive edge beyond cycles. Based in China, we have built our presence all across the world. Relying on our global sales network and after-sales service teams, we provide high-quality products and localized services to customers in over 160 countries and regions. We are present across all time zones on Earth. We strive to stay ahead of the curve. For many years, we have remained in top spot in PV shipment ranking with over 100 gigawatt module shipment around the world. We've been committed to scaling up new heights. As an innovative leader in China's strategic new industry, we are constantly exploring the possibilities of innovation and replicable applications, and consecutively broke the world record for efficiency 19 times. We are committed to energy transformation. We actively invest in the next generation of photovoltaic technology and explore multiple prospective fields, formulating an effective coordination among our R&D, manufacturing, and sales, ensuring first-time value conversion of innovation. Our hard work has paid off with remarkable results. As a major ruler setter in the industry, Jinko possesses a leading intellectual property system. It is a national enterprise technology center and national technological innovation demonstration enterprise. We keep improving until perfection and aspiring to be known for our supreme manufacturing quality. Relying on the advanced smart production line, we have realized informatization for the entire production process. Our modules have won the title of Best Performed for many years, helping Chinese products to gain global recognition. We always seek for a better future. We are constantly exploring the real-life application possibilities for the photovoltaic technology in a variety of fields, including architecture, transportation, production, and living. With the record-high business performance, the ever-expanding market share, and industry-leading growth rate, Jinko Solar, which has landed on the STAR market, will take advantage of the national technology strategy to create a shared future with like-minded partners. Jinko Solar is honored to take on the glorious mission and opportunities by history, to keep leading innovations, fulfilling our responsibilities, and protecting the environment, so as to compose a magnificent chapter dedicated to the photovoltaic industry. Empower a brighter future with solar.
Thank you so much, team, for playing that video. Ms. Charan, we don't have any questions. Oh, we do have a question. We also have a comment if you would like to,
Yeah.
share your thoughts on the same. It's visible on the screen.
Yes, absolutely. So more specifically, I could see that comparative thermal analysis study of natural air cooling versus forced air cooling, where if we just try to understand for a markets like India, which is having moderate temperature kind of zones, where the operating and at 40-45 degrees C, which means the operating temperature of that particular product is going to stand at around like 60-65 degrees C. So under these kind of conditions, definitely it should operate with a kind of forced air cooling mechanism, which means auxiliary consumption definitely is going to be increased if you are trying to go with forced air cooling mechanism. And that has been proved with the past existing containerized solutions, which used to be the inverters. In PV area itself, where during 2012-13 kind of days, where few manufacturers of inverters have came up with a kind of completely containerized solution, which is going to comprise of inverter plus even the transformer, which is a kind of complete comprehensive unit which is having DC input mechanism of combiner boxes plus inverter plus the transformers itself, which are the inverter duty transformer as a kind of entire inverter station itself. So, but that has got a huge auxiliary consumption part, which used to be at very high value when compared with a normal standalone inverters kind of thing, which used to be under IP, which used to be under canopy with IP65 or IP54 kind of environmental kind of conditions. So that way, it is highly imperable that auxiliary consumption for any kind of containerized kind of solutions is going to be more if we are trying to go with forced air cooling kind of mechanism. But the same thing, if you just try to go with the liquid air cooling mechanism, it definitely is going to be reduced. So that way, just to answer his concern in short, if someone is trying to go with a kind of forced air cooling mechanism specific to Indian market kind of conditions, definitely 7 to 8 units of energy per container specific to a 1 megawatt hour kind of container is going to be more. And it will vary from location to location, because specific to the kind of location which is in Rajasthan, which is having higher kind of temperatures, moderate temperatures when compared with the south location, definitely you usually can see 10 to 15% of extra auxiliary consumption of power is what is required in forced air cooling kind of mechanism for these kind of containers. So that way, it is not necessary for Indian market to have a kind of comparative analysis of having a kind of thermal mapping, but just if liquid air cooling mechanism is being provided, which is highly proven, and most of the inverter manufacturers are also trying to consider the same mechanism. So that way, it is very much available in the market to have different case studies on this particular segment, and it is highly helpful in reducing the auxiliary consumption as well. So that way, we can see that at any point of time, liquid air cooling mechanism is highly predominant and it is highly helpful rather than going for a kind of forced air cooling mechanism, which directly is going to increase your auxiliary consumption. How much BESS installation in megawatt hour you expect will happen in India by 2025 and 2030? Yeah, by 2025, if we just try to see almost the tenders, whatever has been out during 2022, which were out from NTPC, NHPC, and SECI. All these particular three tenders together is going to stand at around like 2,000 megawatt hours to 3,000 megawatt hours, and this has got a timeline of around like 24 months to execute, which means these are going to be installed by 2025 itself, not before that. So even 2023 and 2024, if we just try to see during Q4 calendar year of 2024, we can expect that this particular installation is going to happen. And by 2025, we can expect that 1 gigawatt hour more, which means altogether 3 to 4 gigawatt hours can be expected by 2025. And by 2030, if we just try to see this particular 4 gigawatt hour or 3 gigawatt hour is going to touch around like 20 gigawatt hour by 2030. And it completely depends like how the transformation and transition is happening within the entire segments, not just this particular push is just happening from SECI or central government agencies, but also the same thing also has to be followed by C&I market players as well, because most of the players are very well prone towards advanced lead acid batteries just because of the price metric. But yes, slowly and gradually, they also should consider these kind of LFPE kind of technologies rather than going for advanced lead acid batteries. And that particular transition and that particular push from the private sector is required, very much required. And probably if these particular dynamics of these particular prices of lithium ferrous phosphate is going to be reduced within span of 1.5 year to 2 years kind of timeline, we can expect this particular number of 3 gigawatt hours to touch around like not less than 30 gigawatt hours by 2030 is what we easily can expect. Yeah, this is what I have explained in the beginning, specific to comparative thermal analysis. And also he has given the other part like segmented mapping of ESS solution and target customers base in India will be beneficial. Yes, it's like if we just try to look at the market need everywhere, we can see this requirement of ESS. People are talking on this particular ESS part specific to lithium ferrous phosphate kind of solutions rather than lithium titanium or any other lithium ion composition. But if we just try to look at this particular customer base, almost all kinds of existing brownfield projects of PV projects will be very soon will be converted towards this kind of mechanism of having energy storage segments itself, because of the kind of energy security whatever is needed on these particular projects. And not just limiting to that, even on the private sector, more specifically wherever these particular industrial clusters are there, specific to spinning industries or textile industries, they all will be considered as a kind of primary sources to convert themselves, by just adding a kind of extra amount of, extra mile has to be considered by them in specifically adding certain amount of storage capacity within their kitty itself. So that way we can see that private sector wise, these particular industrial segment which are highly targeting within the zones of Tamil Nadu, Karnataka, which are more predominantly working on textile industry, definitely will try to consider this particular ESS part in the beginning. And then we easily can see central government wise, if we just try to see few of the tenders which are being out by SECI or NHPC and NTPC, they also will take the next step together, uh, closely touching around like 4 gigawatt capacity by 2025. So that way we easily can see that. And forced air cooling wise or natural air cooling, definitely natural air cooling is always well defined within the existing inverters itself. So it's not necessary to have any other different thermal analysis study on this. Already many case studies are available in the market specific to PV applications of inverter. Any BSS project has been deployed by Jinko Solar in India? What's your future pipeline with respect to BSS in India? Specific to Indian market, we just entered Indian market, but yes, we have our reference-based installations across the globe. Because our RESS product, we try to provide in three different options, starting from 1 kilowatt hour to 50 kilowatt hours, and that's completely being widely being utilized in North African market and also in North Asian market, specific to Korea and Japan region. And specific to containerized kind of solutions, as I was trying to explain you within the presentation also, that in Nigerian market, most of these particular container solutions has been utilized. And specific to China also, we have utilized this particular BSS of our solution itself, where we have a net zero target by 2025 itself. Already we have crossed, we have touched around like 30% of our factories has been converted towards net zero kind of application, specific to our energy needs itself. And slowly and predominantly for those particular locations itself, for those particular factories itself, we are using 20 megawatt hour kind of solution, which is already in place. But specific to Indian market, we are on the verge of closing most of these particular SECI tenders and NTPC kind of tender. So we are supporting few of our clients, which is going to touch around like 500 megawatt hour, and we are expecting that particular capacity to touch ground maybe probably by 2024. And future pipeline, we easily can see that long way to go. We easily can see that close to around like 10 gigawatt hour tenders are going to be available in the market, and definitely we will take a comprehensive and major chunk with a major market share in that particular segment as well. How ESS could stabilize the grid? Yes, during peak load kind of conditions, definitely the EMS, whatever is there, energy management system, this easily can be programmed as per the grid regulations, or assuming that if 6 p.m. to 10 p.m. or 6 a.m. to 10 a.m. is the peak load kind of condition for a specific grid. So under those particular peak load conditions, the moment when load is being directly consumed by most of the customers, it should be supported, which means that at that particular peak load kind of conditions, the transmission infrastructure is going to be completely congested. So if we can support that particular peak time condition itself with these kind of ESS solution, the congestion whatever is being created on the grid infrastructure specific to transmission line will be stabilized, or it will be reduced. The moment it is going to be reduced, quality power will be utilized with these kind of ESS solutions itself, and these can pump in the quality power into the grid, which definitely will stabilize the grid. That way it will be managed. Yes, we have our commercial solutions available in India specific to RESS product, starting from 1 megawatt hour or starting from 1 kilowatt hour till 2.7 megawatt hour within a kind of containerized solutions is available. Solar plus storage product of a capacity of 1 megawatt, 100 megawatt, 500 megawatt. Timeline wise, if we just try to see, definitely solar is like the moment when you place as an order specific to module within a span of 2 to 3 months kind of timeline, definitely we can provide you the capacity. And it is like depending on the capacity, it completely depends. If it is 1 megawatt, definitely 2 months kind of timeline, or 6 weeks is sufficient specific to module. But when it comes to battery, because these are not having that kind of prudent timelines or kind of proven timelines specific to energy storage or specific to battery part, because we also need to procure these particular batteries, which means the cells from the cell manufacturer. So that way we easily can see that specific to 1 megawatt hour or 1 megawatt hour kind of requirement, we we definitely need, which means as a kind of container, if we just try to speak about, we minimum need 10 weeks to 12 weeks kind of minimum timeline, or even certain times depending on the because this particular trajectory of prices whatever with these kind of lithium ion is going is highly fluctuating. So with that particular sense, even certain times we even can see 3 months to 4 months kind of timelines also. Specific to 100 megawatt or 500 megawatt hour, it completely depends as per the existing tenders, whatever we try to see for Indian market as per the SECI tender. So we are trying to have a kind of initial consortium itself as a kind of collaborative companion with these kind of end users or the IPPs, where we are trying to collaborate with them and trying to provide our support during tendering stage itself. So we have a clear idea of timelines. The moment when they win the bid, definitely we'll have a clear idea of timeline, and accordingly we'll plan with that particular capacity. So apart from lithium ion battery solutions, other battery chemistries, definitely energy density wise, if you just try to see, lithium ion or LFPE is trying to make much more sense, and NMF on the nickel metal hydride, which is having a better sense on the automobile kind of sector, which is more specific to EV kind of segment. But again, like other battery chemistries specific to uh, uh, whether it can be with lead acid or advanced lead acid, or even with fuel cells, which is more predominantly there, which is not even having that kind of power density, and motility is a kind of major concern with those particular segments. And safety wise also, uh, the kind of the kind of safety concerns which generally will be addressed with this kind of LFPE is far better when compared with any other battery chemistries, which is why most of these particular battery solutions or the energy storage solutions are majorly getting captured with this kind of lithium ion kind of solutions. And vanadium redox is one other kind of solution within the entire area. But yes, it is not having the kind of compatibility what lithium ion is having in the market, which is why we can see very limited players having scope in optimization or improvisation as what the energy density of lithium ion or the power density which generally lithium ion or LFP portrays when compared with vanadium redox or any other fuel cells kind of thing. Yes, of course, pumped hydro is the moment when they go in mass, when they go in a big scale, definitely it will have higher benefit, but it's not applicable to every region on every location. So pumped hydro is limited for very specific locations, which is why one of the big IPP in Andhra Pradesh is trying to do that, which is there close to around like 3 gigawatt to 5 gigawatt hour kind of requirement. But the moment when it comes in megawatt hour, definitely pumped hydro will not make any kind of comprehensive sense. So, but yes, in gigawatt hour scale, it makes comprehensive sense, and also it occupies more amount of space, and specific to location only they can be considered, which is why the existing tenders also specific to one of the SECI tender, and they have considered this particular pumped hydro. But yes, it is again like very large scale kind of capacity. Comparatively, it will have best LCOE kind of configuration when compared with lithium ion kind of solution. But again, it's like it depends on the scale. So for any kind of containerized solution, if we try to compare container LFPE solution versus pumped hydro, definitely LFPE makes more comprehensive sense. But if you try to compare one simple gigawatt hour kind of solution or 3 gigawatt hour 5 gigawatt hour solution with existing LFPE, definitely pumped hydro makes more sense. So it's only limited to large scale capacity, and it is having its own constraint on area occupancy or specific to location, and that particular water resource has to be there. So many other challenges are there. Not everyone can do that at every scale. Yes, we even have showcased one of the products specific to residential ESS part, where it is showing starting from 1 kilowatt hour to 20 kilowatt hours or 50 kilowatt hours kind of requirement, which we generally call it as RESS. So we have three different products. Probably you can get back to us, where we will try to provide you our data sheets specific to your market, because again, that even will be configured as per the grid code regulations of that particular specific market.
All right, great. That was a really interactive session, and I think that's all the questions that we have for today. So, thank you so much, Mr. Charan, for an insightful presentation. And thank you, all our attendees, for investing your valuable time and support for the event. We promise to be back with more exciting sessions. Have a wonderful weekend, everyone.
Thank you so much, everyone, for joining this particular session. I once again regrets for the inconvenience, for the delay, whatever has happened. Thanks, Sakshi, and thanks, First View team, for this particular session to be organized in such a wonderful manner. Thank you so much.
Thank you so much. Goodbye, everyone.
Bye.